Okay, in this lesson we're looking at section 12.4, box and whisker plots. Now, this is another way to represent data other than the charts and the graphs that we've seen so far. The box and whisker plots have a few different parts to it, so we want to start and kind of look one step at a time. So here for vocabulary review, it says percent means parts per 100. Percentiles, they separate a data set into 100 equal parts. So percentiles separate data into 100 equal parts. Write percent or percentile to complete each sentence. So let's make sure we have an understanding of the words. In a bag of coins, 20 of the 80 coins are pennies. So 25 blank of the coins are pennies. Well, which one makes the best sense in this case? The word percent, because 20 is 25% of the coins that are pennies. Ah! Okay. No, I don't do anything with that. Yeah, I'm sorry. Okay, sorry about the disruption. All right, so a score at the 70th blank of a data set is greater than or equal to 70 blank of the scores. Well, here we have two blanks. We have a blank here and a blank here. So our first one is going to say a score at the 70th percentile, so it's broken up into equal parts, is greater than or equal to 70% of the scores. So that's how you use both of them together in a sentence. Now moving on and looking at the rest of our vocabulary builder, we have a new word here called quartile. A quartile is one of three values that divide a data set into four parts. Remember, the word quartile starts with quart, which is similar to, let's say, a quarter of something, which is 25% of something. Like 4 quarters go into a whole dollar, okay? So a quartile is one of three values that divide a data set into four parts. So instead of divided into 100 equal parts or percentiles, quartiles divided into four parts, the whole set of data. And so here, the way we would use it in math usage says, the median or second quartile separates the data into the upper and the lower halves of information. You see an example here, you have the numbers listed from least to greatest from 8 to 31 of the data that's given. And what they did was they split it straight down the center. And then from straight down the center, this is the lower half, and this is the higher half of the numbers. So right from the middle, the lower half of the numbers are to the left, then the upper half of the numbers are to the right. The first quartile now is the median of the whole first half set of numbers. So when we're looking at this, we're taking our whole data range, we're finding the center of this here, the second quartile, and that divides our data into half. And then we're going to find half of the first set, half of the lower half, and half of the upper half. That makes our first quartile and our third quartile. So you have your first quartile, your second quartile, and your third. The first is half of the first half of the information. The second is half of the whole set of information. And the third is the halfway point for the upper half of the information. So there's three different points where we're making a mark here. But notice it does divide our information up into four parts because 3 breaks makes 4 separate sections. So a related term that we have here is interquartile range, which is the difference between the third and the first quartiles. So in this example above, we would look at the first and the third. We're not paying attention to the second quartile at this point. So we're going to see from here to here, we already know the word range, but this is new where it's the interquartile range, where we're going to subtract 30 minus 11, which would give us 19. So our interquartile range would be 19, the difference between those two. Totally different from what would be our normal range when we look at measures of central tendency, where we would have done 31 minus 8. Okay? So let's see how we can apply this information here. Write true or false for each of the following here. So number 3 says the quartiles of a data set divide the data so that each part has the same range. Well, we've never talked about anything having the same range, so that has to be a false statement. The next one says the quartiles of a data set are divided, the quartiles of a data set divide the data so that there is an equal number of scores in each part. Well, the quartiles of a data set are going to make sure that there's an equal number of scores in each part. That's why you're dividing in chunks, like in half, then in half for the first part, and in half for the second part. The other thing we're looking at, the second quartile of the data set is greater than about 50% of the scores. Find the second, okay, so the second quartile of the data set is greater than about 50% of the scores. That one is going to be true because if you look at wherever your second quartile is like your halfway point. So basically the whole lower half is lower than that score. So yes, it's greater than about 50%, and that's a key word there, about. So it says find the second quartile for each set of data. Well, the way we find the second quartile is number 1, they're already listed for us. The data set is already listed from least to greatest, and we have to find what is the middle number. So I'm going to come over 2, over 2, over 1, over 1, and 21 is right smack dab in the middle of that data set. So coming over here for number 7, I take a look at, and I will find the center of that data as well. Remember that center number is called the median or middle number. Well, I'm going to come over 3, but now look, I have 2 numbers smack dab in the middle. Do you remember what to do to find the median of the 2 numbers that are here in case you have an even set of numbers? Well, what you're going to do is you're going to find the mean of those numbers. So between 30 and 32, well, that's kind of easy because the middle number between that is going to be 31. So here our second quartile is at 31. Notice you don't see 31 listed here. That is perfectly okay. Let's go on to our next page. So here it says what are the minimum, least value, the first quartile, the median, the third quartile, and the maximum or greatest value of the data set. So here they want us to kind of go ahead and put everything in order. The first thing we want to do is take this entire data set that we have been given, and we do want to arrange it in order from least to greatest. Then we can go ahead and circle the median. So looking here, we have 60, 65, 75, 2 blank spots. Well, if you notice, the 60 is here, 65 here, where are we? I like to cross numbers off as I use them. So I have a 75. The next highest number I have is another 75. Then I also have a third 75. Then it looks like 85, 85, 85. I can cross each one of those off. 95, 100, and the last number left there is 105. So I have arranged these in order from least to greatest. So my minimum data value here is going to be the smallest number, which is 60, and my maximum data value here is going to be the highest number, which is 105. So what we're going to do is here, write each data value from exercise 8, that's what we're working here, in the correct box. The values to the left of the median. Well, that means we have to go ahead and find the median, which it did tell us before, circle the median. Well, in order to circle the median, I have to count over. So let's say I'm going to go 3, 3. So I eliminated those. I'm going to say 2 and 2. I eliminated those. So the number that is smack dab right in the middle is 85. So it says write each data value to the left of the median. Well, everything to the left of the median is here. So that's 60, 65, 75, 75, and 75 again. That takes care of this list. And the values to the right of the median over here, there's 85, 85 again, 95, 100, and 105. So those are all the values to the right of the median. Notice we did not include the median in either one of those sets of information. Now we can take a look at what's going on here. Complete the first sentence, then underline the correct word to complete the second sentence. So in the first sentence it says here, the median of the numbers to the left of the median is blank. Well, what they're asking us is they're saying all these numbers that were on the left of our original median of 85, what is the median of that set of numbers? So here, I'm going to go into, come into, and I do have a smack dab center right there, which is the number 75. This is called the first quartile, so I'm going to underline the word first. 75 is our first quartile. Now, the median of the numbers to the right, so this was over here, so I come into, and look at that. 95 is the median of the set of numbers to the right of our original median of 85. So this is the third quartile. So here is how we put this information all together. Remember, our second quartile, also written as Q2, was 85. That was the original median. Our first quartile, also called Q1, was 75. And our third quartile, also called Q3, was 95. We're going to go ahead and use this information here. And this is where we come into creating a box and whisker plot. All right, so up until now, we have worked with the information and found our 3 different medians. The median of the whole group, the median of the numbers to the left, and then the median of the numbers to the right. A box and whisker plot is a graph that summarizes a set of data by displaying it along a number line. So a box and whisker plot starts with a number line. It consists of 3 parts: a box and 2 whiskers. Whiskers kind of come out like that, okay? So here's how it looks. Here is your number line, and your median, wherever your Q2 is where you would put a dot. So let's say here. They have one listed right here. Now, once you found your Q2, that's where you start. So our Q2 here was 85. So I would judge this to be right about 85. The minimum value on our entire list was 60. Our maximum value on our entire list was 105. So wherever that falls on the number line, you would make a point at your minimum, a point at your maximum, a point at your median, which is also called quartile 2. The only other 2 points you need to make are for quartile 1 and quartile 3. So for an example, quartile 1, we had 75. So there was a dot here, that would literally represent 75. And then over here, our quartile 3 would have been at 95. So we would have 5 dots. The minimum, quartile 1, quartile 2, quartile 3, and the maximum. The way our box works is you create a box, there's a line through the original median of the entire data set, there becomes a line over here at each of your quartiles. And when you create this box means this is your interquartile range. That was the one we saw on the previous page where we're going to take the range between the median of quartile 1, the median of the first set of data, and the median of the second half of data. And this is our range, also called the box. This is where the majority of all of your information or data set should fall. Then the whiskers just go out from the box to the minimum and to the maximum. We're going to have some good practice with this here in a moment. So making a box and whisker plot, this is problem number 2. Let's start the process over again to see if we get it. So first thing we're going to do is order the numbers from least to greatest. So I'm going to start here with a 4, 8, 9, 10, 14, 15, there's 2 16s, I'll record that twice, 25, and then 34. So now I have my data presented here for us. I want to go ahead and find the middle. I'm going to go 3 in, 3 in, looks like I can go 2 in, 2 in, and I'm stuck between 14 and 15. The middle of 14 and 15 is 14.5. Let me go forward to the next page. So we're here, and that means 14.5 was my median. Okay? They told us the minimum value was 9, and the maximum value was 34. Well, how did they get that? Well, here, my minimum value was actually 4, and here it was 34. Let's see if that, I might have said that improperly. This should be a 4. All right, so your first quartile, so in that whole set of data, let's go back. Our first quartile is going to be between, these were all the sets of data, let me do this in black, for the first half. So I go into, circle the middle, 9 is Q1. Over here, I go into, 16 is Q3, which is what they did have represented here, and I believe they did have a typo. They have 16, this 9 should be your Q1, and this one here is our minimum. I think they just swapped these two here. And so coming across, we're going to use this information that we just found to create our box and whisker plot. So remember, the minimum value is over here. This is a 4. Well, let's start here. I think they put all the data values in here. Let me look and see how they ordered this. Yeah. So in the center, we have our 14.5. We have our 16, and over here we have our 34. We have a 9, and we have a 4. These are the 4 sets of information we needed to derive from the data set, our original data set. I wouldn't worry about down here right now. They numbered it from 0, 4, 8, 12. They did increments of 4 from 0 to 36. So 0, 4, 8, 12, 16, 20, 24, 28, 32, 36. I want to stop there and see if we have some understanding, and I want you to go ahead, do the rest on your own, and we'll check back in a moment to see if you got it.